Professor Dr. Johan Rockström, Director of the Potsdam Institute for Climate Impact Research, Professor in Earth Systems Science at the University of Potsdam, Professor in Water Systems and Global Sustainability at Stockholm University, NUS Deputy President of Research and Technology, Professor Liu Bin, distinguished guests, ladies and gentlemen, a very warm welcome to the NUS120 Distinguished Speaker Series lecture, Navigating Our Future Within Planetary Boundaries. I am Min Hui, a fourth-year student from the Faculty of Science, and I'm honored to be your Master of Ceremonies for this afternoon. The NUS120 Distinguished Speaker Series brings together inspiring global voices to share fresh perspectives on some of the most pressing challenges shaping our collective future. Centered on the theme Shaping the Future, it aims to spark meaningful ideas and lively discussion. This afternoon, we are truly privileged to have with us the eminent Professor Dr. Johan Rockström. Professor Rockström is internationally recognized for his contributions to the Planetary Boundaries framework, which explores how human pressures affect the stability of the planet. Today, he will share recent insights into the state of the Earth's system and discuss ways we might remain within the limits that sustain a resilient planet. We are also delighted that Professor Koh Lian Pin, NUS Vice President of Sustainability and Resilience and Chief Sustainability Scientist, will be joining us later to moderate the question and answer session. To begin the program, may I invite NUS Deputy President of Research and Technology, Professor Liu Bin, to say a few words. Professor Liu, please.
Good afternoon, everyone. Welcome to the NUS120 Distinguished Speaker Series. Today's lecture focuses on what is arguably the most pressing concern of our time, the environmental crisis of planet under strain. We face a planetary emergency where the evidence of ecological stress is visible, measurable, and increasingly alarming. We are witnessing record heat waves, rising sea levels, vanishing ice caps, and ecosystems pushed to the brink. I am privileged today to welcome Professor Johan Rockström, Director of the Potsdam Institute for Climate Impact Research, one of Europe's leading centers for climate change and sustainability research. As the eminent scientist in global sustainability, Professor Rockström's pioneering work centers on the Planetary Boundaries framework that monitors the impact of human development in the era of rapid global change. He is deeply involved in research on the future trajectory of the Anthropocene at major tipping points, destabilizing the Earth system. Since its introduction in 2009, the Planetary Boundaries framework has emerged as a fundamental tool to monitor the Earth's capacity to sustain humanity. It serves as the barometer to measure the health and stability of our planet through 9 system indicators that regulate the balance of the climate, oceans, polar regions, and natural habitats. As the institution that champions a sustainable future, the National University of Singapore pursues interdisciplinary solutions in education and research. Our latest initiative, NUS Sustainable Futures, built upon our strong research ecosystem to tackle the complex and integrated challenge of climate change. I am delighted today we will be taking our commitment further by partnering the Potsdam Institute for Climate Impact Research to advance research in fields of global change, climate impacts, water, energy, and sustainable development. This will allow us to exchange valuable expertise, information, and ideas for successful collaborations. This seminar today marks the beginning of this vital exchange, and I look forward to the exciting insights that Professor Rockström will share as we race to recalibrate the future of our planet. Thank you.
Thank you, Professor Liu. And now, ladies and gentlemen, please join me in welcoming Professor Dr. Johan Rockström to the stage to deliver his lecture. Prof. Rockström, please.
Dear colleagues of National University Singapore, dear citizens and friends of planet Earth, let me here give you a science update of why we are today, for the first time in our presence on planet Earth, forced to address the following question. Are we at risk of destabilizing the very state of the planet? Are we now at risk of undermining the stability and the life support on planet Earth? This is the point we've reached. We have ample scientific evidence today that we're hitting the ceiling of hardwired biogeophysical processes that regulates the very functioning of the Earth system. We've known for a long time that Mother Earth is a unique place for life in the universe. But what we're increasingly learning is also that the planet has multiple stable states, and that the health of the system, the ability of the Earth system to remain in the state that we depend on for our lives, is regulated by biogeophysical systems that fundamentally can be analyzed based on tipping point dynamics, which requires us to quantify a safe operating space to avoid triggering irreversible changes that can make us drift away from the state that we all depend on. And I here want to give you this story, the story of the science behind the planetary boundary framework, but also the story of concern of why we're starting to see increasing evidence that the planet may show now the first signs of losing the resilience and buffering capacity that we've been so privileged to be able to rely upon during the entire journey of the industrial pathway that we've been following over the past 150 years. But then I want to really connect that to the planetary boundary science and how that can guide us towards a transformation with a safe landing back within a safe operating space, and what this can mean for our own prosperity and equity. So let's go. Well, the first part is really this concern that we're starting to see the first signs of accelerated warming on planet Earth. This is incredibly concerning that we're seeing from the 5 independent sources of measurements of air temperature to the left and sea surface temperatures to the right. You all have seen these hockey stick curves. Up until the mid-1960s, we have kind of a flat curve, and then it starts rising linearly from the 1970s up until the 2010s. The rate of warming is scientifically proving unequivocally related to our emission of greenhouse gases for fossil fuel burning and land degradation. We also know that this is what has led us to the conclusion that we are in a climate crisis, because we've reached 1.3 degrees Celsius of average temperature rise since that point. And this is what translates to all the climate policy, the Paris Agreement, to reach a net zero world economy by 2050, all the efforts of holding temperatures by 1.5 degrees Celsius of maximum allowed warming, while doing it in an orderly fashion that can take us to a decarbonized future. But unfortunately, what you see over the past 10 years is a sudden nick of the curve, that we're starting for the first time to see something unexpectedly happening. We're not raising, the curve of emissions is not going in a steeper form. On the contrary, actually, we're starting to see the first efforts of bending the curve of emissions from fossil fuel burning. Still, the warming is happening faster than before. What is happening? We see it both in sea surface temperatures and on land. Now, there's a lot of scientific discussions about this. One source is very likely that 2024 was an El Niño year, so you have a natural bump up because of the release in heat from the Pacific Ocean, but that cannot explain it all. There's also an explanation that the fact that we are cleaning up the cities, coming back within the safe space of one of the 9 planetary boundaries, namely on air pollutants, cities like Beijing, but also commercial shipping, that this has a paradox that cleaning up the air has this tremendously positive impact on reducing impacts on human health, drawing us back from the 7 to 8 million people that prematurely die because of air pollution, which is a tremendous benefit for human health. But at the same time, the air pollution is a form of geoengineering because it reflects back incoming ultraviolet radiation, which actually cools the planet. So cleaning up the air bumps up warming in what Jim Hansen has postulated as a Faustian bargain, that we are in a lose-lose situation. Well, this also can explain part of this increase, but not all of it. There has to be more to really explain why we're now suddenly having 0.3 degrees Celsius of warming per decade instead of 0.2, which we've experienced since the 1970s. And this is where it gets really concerning, because the only source of explanation is if there are changes in feedbacks in the Earth system, that there's changes in cloud dynamics, that there are changes in albedo, that the planet is getting darker because of ice melt and changes in forest cover when forest systems climb further to the north and to the south, but also that we're seeing the first signs of reduced carbon uptake capacity in terrestrial ecosystems on land. All of these are not changes in forcing, like changes in air pollutants or changing in our fossil fuel burning emissions, which are serious enough, but they're changing in the very functioning of the Earth system, in the very resilience and buffering capacity of the planet. And if this starts occurring, if the planet starts showing signs of losing its strength, then of course we may see a drift. The curves may be a start of a change in climate sensitivity. It may be a more permanent shift in the strength of the system, which would in turn translate to even less space for carbon emissions for an orderly phase out of fossil fuels. It would actually mean that phasing out fossil fuels by the mid of 2050 for a net zero carbon economy would not be sufficient, because we would have to phase out fossil fuels even faster. So this is a first sign of concern. And this was the origins of the planetary boundary science in the very beginning, when we in 2009 addressed the question, what defines the resilience of the planet? What defines the regulating capacity of the planet to remain in a stable state? And we started to quantify the 9 planetary boundary systems, which then were all focused on keeping the planet in a healthy state. And now, 15 years later, we start seeing that we were on a right track, because we showed already then that 4 of the 9 boundaries were breached. 5 years later, we concluded that 6 of the 9 boundaries were breached. Today, we have to conclude, 3 weeks back, that 7 of the 9 boundaries are breached. The planet is indeed moving increasingly towards a point where we are pushing it to positions of losing strength. Now, this is where we stand today. And what brought us to that point? Well, there were 3 sources of evidence. The first one is the pressure points, that we are today not only in the Anthropocene, we're deep into the Anthropocene. I'll come back to this. The second one is that, which is fantastic, science over the past 30 years have done so tremendous advancements in paleoclimatic research, showing us that we have ample evidence that the Holocene, the interglacial warm equilibrium state of the planet since we left the last ice age, is not only a unique equilibrium state of the planet, it is the planetary state that we all depend on for our civilizational development and for the world as we know it. And finally, that the planet is a self-regulating system with tipping points, cross their thresholds, and we risk shifting feedbacks, which means losing the buffering and stability of the Earth system. The first evidence then is the Anthropocene. It's the speed and the scale and connectivity of a planet that is now at a point where I define it as having reached a saturation point. We have all the evidence here. This is the great acceleration curves that have been, let's see, the clicker has for the moment paused. I was going to show you the great acceleration curves that we presented at the New York Climate Week just a few weeks back. I might need help with... is it? There we are. Okay, let's hope that it continues working. This came out the first time 2007, run by the International Geosphere Biosphere Program. It's a phenomenal set of data. It's observations of the great acceleration, which is the evidence behind the Anthropocene. Anthros, Greek for humans, that we are now the dominating force of change on planet Earth. The blue curves are the socioeconomic pressures. The green curves are the impacts on the Earth system, from carbon dioxide down to loss of biodiversity. The x-axis is our entire journey from the invention of the coal-fired turbines in 1750 up until today. You see that we have linear change up to a certain point, and then off we go in this exponential rise. The point is quite exactly set to 1950 to 1955. That is today defined as the moment of the great acceleration, and then off we go in the exponential rise of pressures, and today we've reached the top of these curves. And unfortunately, most of these curves continue rising upwards. And that is where we have now concluded that we've reached this point where we're starting to bump to the ceiling of the capacity of the Earth system to continue to deliver at a stable state. In short, it means that up until somewhere, my assessment is, this is not published yet, but my assessment is that somewhere around 1980, 1990, up until that point, the planet, was so, still having such abundant capacity to allow unsustainable exploitation, both of the atmosphere, ecosystems on land, fisheries in the ocean, that the system did not send invoices back to the economy to a significant extent. It could still allow for the unsustainable economic development pathways that the world had been running on and still is running on. But from that point on, we start seeing a shift where there is no more atmospheric space. We simply pass the 350 ppm planetary boundary on climate. We fill up all the fish stocks in the ocean. We don't have any more forest systems that can be transformed into agriculture or urban areas. We simply reach the boundaries of what the planet can tolerate. And that is evidence piece number one. We are at this pressure point where we can go no longer in unsustainable pressures. The second piece of evidence is the reference point to the planet we depend on. I call this the corridor of life, that the Holocene is the period that we depend on for our development. And here you have the evidence. This is a phenomenal update of the journey of planet Earth over the past 1 million years. You will see here 500,000 years. The first plate is the last 20,000 years. On the y-axis here, you have global mean surface temperature. The 0 point is the pre-industrial 14 degrees Celsius planet. You see that we were in deep ice age at -5. We are a few million people on planet Earth. We're hunters and gatherers. We live in caves. We have a rough time. We've been around on planet Earth as modern humans for 250,000 years. We leave the last ice age, and we enter this extraordinarily stable Holocene period that hovers around this zero line, and we barely enter it, and we go through the Neolithic Revolution. We domesticate animals and plants, and off we go in the civilizational journey that brings us to the NUS Aula for the 120 celebration just today, the modern world as we know it. Now, what we know is that the great acceleration is pushing us outside of this range of variability. We are in 2025 at 1.3 degrees Celsius. We're following a pathway that will take us to 3.1 degrees Celsius of global mean surface temperature rise just in 75 years by the end of this century, 3 generations. That 3.1 degrees Celsius line will imply winding back the climate clock 3 million years. Actually, the last time we had that temperature, as far as science shows today, you have to go outside of the Quaternary. This allows us to define what I call the corridor of life. The narrow corridor of life you see here is the one that we depend on for the development of civilization as we know it in this room. It's a 14 degrees Celsius planet plus minus 0.5 degrees Celsius, and you have all the variability since we invented agriculture and developed the civilizations and the journey up until today. If you wind back further, and you want to go 3 million years back, the evidence show that we never exceeded 2 degrees Celsius of warming, the warmest point, warm interglacial, and the long ice ages took us to minus 5 degrees Celsius. So, however we twist and turn this, there's absolutely no evidence that we can support humanity as we know it, the world as we know it, in a responsible way outside of the wide corridor of life. Go beyond 2 degrees Celsius and you enter unknown terrain. I therefore call the journey we're on today, the journey that would take us to 3.1 degrees Celsius by the end of the century, as a path to disaster. It cannot be articulated in any other way. But this is also a very, very important piece of science, as you can imagine, because it gives us a reference point that we can measure against when we quantify the safe operating space to keep the planet as close as possible to remain in the equilibrium state of the Holocene. So that is evidence number 2 for the planetary boundaries. We have now also more and more monitoring of this. This is a paper that will be coming out in a few weeks' time. It's updated every year, the state of the climate system. This is the state of the climate system 2025. I won't go through the curves here, but it's just the unfortunate conclusion, come as no surprise to you, that the curves continue moving in the wrong direction. These are the curves of carbon dioxide, nitrous oxide, methane, sulfate pollutants, the Earth's energy imbalance continue rising upwards. And to the right, you see just a reminder of the pace of change. Here you have 12,000 years of stability in terms of temperature, and then you have the spike, which is the vertical line of unprecedented pace of warming caused during the Anthropocene. The third and final part of evidence that brings us to the planetary boundary framework is that the planet has tipping points. These are the hardwired biophysical systems that contribute to regulate the state of the climate system, and they have multiple stable states. And what keeps them in a healthy state, the state that we depend on, is that they're dominated by negative feedbacks. They're dominated by dampening feedbacks, or think of them as cooling feedbacks. So that's quite interesting. A stable ice sheet, a functioning coral reef system, a stable rainforest, not only does it supply us with ecosystem services that we depend on for food security, water security, air quality, everything that is the basis for our lives, but it also regulates the very livability on Earth. These are global commons that we all depend on, irrespective of where we live on planet Earth. The Intergovernmental Panel on Climate Change, the IPCC, has been mapping these tipping points. There's a table, 4.10, in the Working Group 1 report of the AR6 that summarizes the list of these tipping points, because we're increasingly nervous that if we push them too far, they would go from cooling to warming the planet. The IPCC concludes in the 6th assessment that there are qualitative statements on these, no quantifications. There's kind of low to medium confidence levels and high degrees of uncertainty. This is data from 2019-2020, but we've now done an update. We do the update as science inputs to quantify the planetary boundaries, because the planetary boundaries is about avoiding to cross tipping points. Set the boundaries to stay safe, distance from the tipping points. Here you have the latest update of the 16 climate tipping elements. They are across the entire planet. 6 of them are up in the Arctic region. You'll recognize some of them. The Greenland ice sheet, which represents 6 to 7 meter sea level rise. You have the Barents Sea ice, you have the Labrador Sea, you have the AMOC in the North Atlantic, you see the Amazon rainforest there. 3 systems in Antarctica. The West Antarctic ice sheet is the one that we're most concerned with today. And then you have the tropical coral reef systems that were 3 days ago declared in the 2025 Global Tipping Point Report as being the first planetary tipping point system on the line of crossing a threshold. And here you have the quantifications. This was published in 2022 in a major paper in Science led by David Armstrong McKay and colleagues. You have the 16 tipping point systems. You have uncertainty ranges in red. It's done through an IPCC burning embers methodology. The further to the right and the deeper the color, the higher is the confidence of crossing a threshold. You see temperature on the x-axis, global mean surface temperature rise. I just want you to look at the top 6, which has the dots, which are the median estimates. And what you see is 6 systems that are likely to cross the thresholds if we exceed, more permanently exceed, 1.5 degrees Celsius. The Greenland ice sheet, the West Antarctic ice sheet. These two ice sheets represent 10 meters sea level rise. Now, nobody is suggesting that if we cross a tipping point, that we would suddenly get a tsunami and a flood of 10 meters. But what would happen, which is very relevant from a Singapore perspective, is that the rate of sea level rise would increase and it would be unstoppable. You would have crossed a physical threshold where you could not turn around, at least not from what we understand today. So you would have a situation where the IPCC's assessment currently of having up to 1 meter sea level rise by the end of this century as a median, but as you may remember, the IPCC says that there's a huge uncertainty and that it could reach 2 meters by the end of this century. Well, if we cross a threshold, we are more likely to reach the 2 meter level than the 1 meter level. The rate of change would increase, and it would potentially take 1,000 years for the entire Greenland ice sheet to disappear. That would mean 7 meters, but it would be unstoppable. So this is why these thresholds are so significant and so important, and they have immediate impacts and long-term impacts. But look then at tropical coral reef systems, abrupt thawing of permafrost, collapse of the Labrador Sea Current, and collapse of the Barents Sea ice. This is the kind of evidence we use to set the boundaries, because we assess that these risks cannot be acceptable. These are not risks we can take, and they would push the Earth system to drift away from stability, so the boundary has to be set below that. Look at the Amazon rainforest, which is the fourth one from the bottom. You see a huge uncertainty range from 2 degrees to 6 degrees with a median at somewhere around 3.5 degrees Celsius. Put that in the back of your mind, because I'll be criticizing that number in the following slides. But you may ask, of course, well, one science paper, does that really mean that there's a consensus across the scientific community that there's a risk of crossing tipping points already at 1.5 degrees Celsius? Well, my answer is that yes, we are heading in that direction. Here you have the proof. 5 IPCC assessments. This is quite a remarkable journey. 25 years of climate science consensus building through 5 IPCC assessments over 25 years. Here you have the part of the IPCC that shows the burning ember assessment of risk of causing irreversible tipping point dynamics in the Earth system. 25 years back, the assessment was that the risk could be somewhere between 5 and 6 degrees Celsius of warming, which means very low risk, essentially no risk. I mean, nobody was suggesting that we would reach that level of catastrophic warming. But look at the arrow as knowledge advances. The more we learn about the planet, the more we understand how Mother Earth operates, the lower is the temperature range of risk. And just to be really assured that I come across here, this assessment is not based on our emission of greenhouse gases. It's not based on our unsustainable pressures. This is just based on Earth system science, analytics of how does the system work? How does the biophysical engine operate? How does the resilience function? How strong is the biogeophysical systems? And the conclusion is not so strong. Already somewhere between 1.5 and 2, we risk crossing thresholds. So there we are on the evidence. And let me then be myself then self-critical. And let's see, it won't allow me to be self-critical, and it wants to be a bit nice to me in this case. If we take the next slide. There we are. Here we have one of the tipping elements, the largest and richest biome in the terrestrial ecosystems on planet Earth, the Amazon basin. In terms of biodiversity, in terms of freshwater recycling, in terms of carbon stock, 100 petagrams of carbon stored in this system. In red, you see the deforestation, the 17% of deforestation so far, which is eating itself into the system from the southeast. I showed you the 3 to 5 degrees Celsius of climate analytics in terms of risk. But if you introduce a planetary boundary framework to the analysis of sensitivity of the system and bring in biodiversity change, deforestation, and shifts in hydrology, the conclusion is today that if we lose more than 20 to 25% of the canopy cover, meaning that we open up the forest so it loses its humidity and moisture recycling capacity, the system is likely to cross the thresholds already somewhere between 1 and 2 degrees Celsius of warming. This means, to quote Professor Carlos Nobre, I would argue the world's most recognized scientist on climate and ecology in the Amazon, what he said just 3 weeks back in New York, we are very close to a tipping point in the Amazon basin because of the combined pressures from biodiversity loss, deforestation, changes in hydrology, and heat. So this is why we need this integrated framework, and we use this evidence to set the safe boundaries across the different systems. Now, to add final piece of scientific frontier in this work, we have more and more evidence that the tipping point systems interact and have domino cascade connections. And I take this up just because the most concerning one today is the AMOC. So what you see here is that we have more and more evidence that when the Greenland ice sheet and the Arctic system melts very fast, releasing fresh water, which dilutes the thermohaline engine that drives the AMOC, because the AMOC is driven by warm, high-density saline surface water flowing from the Southern Ocean, reaching the Greenland tip, releasing heat into the atmosphere, which determines the regional weather conditions in the northern parts of the hemisphere. This heavy saline water then sinks, and it drives the engine and pushes back water on the ocean floor, and it comes back to the Southern Ocean, and it continues circulating. This gets diluted from melting ice. It gets diluted from precipitation, from global warming, which increases precipitation, and the system slows down. It has slowed down by 15%, according to the latest assessments. This slowdown can impact on accelerating the dieback of the Amazon forest, but it also means, of course, that warm, high saline surface water gets to a larger extent stuck in the Southern Ocean, which can explain why the West Antarctic ice sheet is melting faster than we had expected. So the conclusion is, not only are we sitting here in Singapore having to recognize that, yeah, these tipping element systems are global commons that we should all care about, but also that what's happening in one corner of the planet, the Arctic, is connected all the way down to Antarctica, which means that these systems are interconnected, which of course means that we have to be even more careful. And why do I bring this one up in particular? Well, it's because the IPCC states that the risk of a shutdown of the AMOC is very low. It has low confidence, meaning high uncertainty, but also low probability, which may be related to the fact that we have low confidence, but that's another issue. Because over the past 2-3 years, there's been so many new scientific studies showing that the AMOC shutdown is actually not a low likelihood occurrence at all. There's so much new evidence, and this is the latest one, showing that even at intermediate emissions over this century, meaning if we continue business as usual as today, there is, according to these latest runs from Utrecht University, a 37% likelihood of a shutdown of the AMOC by the end of this century. That is a tremendously high likelihood for a catastrophic impact, because the impact of a shutdown of the AMOC is that it would increase the rate of warming on the entire planet, and it would change the monsoon systems and therefore rainfall patterns at continental scale, and it would have abrupt changes in livability in the northern hemisphere. So when you think of risk being equal to probability times impact, and if the impact is unacceptable, which I would argue that AMOC shutdown is, then of course a likelihood of over 1%, and in this case over 10%, is completely unacceptable. This is why 44 scientists half a year ago signed a letter to the prime ministers of the Nordic Council of Ministers meeting in Reykjavik in Iceland to say, look here, this is something that you should take very seriously, and it should help us in the climate action space. So just to show that I would argue that the tipping point science, which guides the planetary boundary science, is a question of supporting climate action. It's not a way of just warning us of risks. But the question is there. We need to consider it. Are we at risk of drifting away from stability? Are we at risk of pushing ourselves out of the equilibrium attractor of the Holocene? And the conclusion today is that as far as science is today, I mean, so far I've shared with you the update on risk, but still the conclusion is that we've not pushed ourselves out of the equilibrium state of the Holocene, but we are very close to the edge, and the question is, are we at risk of drifting away towards a self-amplified future that would mean that the planet self-warms towards a hothouse Earth state, Or can we transform ourselves into a manageable Holocene-like state? That, in my view, is like the ultimate question we today need to address regarding our future. Now, this requires guiding through the planetary boundary system. And I can take the next slide. And it requires understanding, for example, how are we doing in terms of the resilience of the components of the Earth system? And here you have one piece of the most important sources of evidence there. This is, several of you have probably seen this, is the Global Carbon Project that updates every year the global carbon cycle, the most dominant greenhouse gas cycle. From 1850 until today, you see billion tons of carbon on the y-axis. The red and orange are the emission of greenhouse gases in red and land use change in orange. Is it all of this that has been accumulating in the atmosphere causing the warming so far? The answer is no. The dark green part is the absorption of carbon in the ocean, and the light green is the absorption of carbon in intact nature on land. It's only the blue sliver there that has remained in the atmosphere, causing the climate crisis we're in today. And even a kid seeing this graph would immediately react, isn't this quite remarkable that the more we stress Mother Earth, the more she's helping us. And this is exactly what we've experienced over the last 200 years, that the biogeophysical resilience of the system has been remarkably high, removing roughly 50% of carbon dioxide every year despite our unsustainable pressures. Unfortunately, the green line there, you may have a sense when you look at it that it's starting to show a sign of leveling out, and that is exactly what we're seeing. We're seeing an increasing piece of evidence that from multiple sources of published research, that the carbon uptake capacity in forest systems is going down. And I'm not sure if you're aware of this, but the Brazilian part of the Amazon basin has already flipped over and is no longer a carbon sink. It's actually a net carbon source. So this is a sign of a system that may be moving towards a more fragile state. And in addition to that, we are now moving beyond the boundary on climate. So we have a real challenge on our watch. This is the 2020 to 2100 assessment from the IPCC's most ambitious climate scenarios. The 1.5 degrees Celsius, for those of you who are in this business, the RCP 1.9, C1 in blue and C2 family of scenarios in magenta. Now, we concluded at the Potsdam Institute that the blue scenarios that basically do not exceed 1.5 degrees Celsius are no longer an option for us. That door is closed because we have unfortunately not bent the curve of emissions yet. We continue loading so much heat, which is in the pipeline, that we unavoidably will head towards overshoot. So from what we know today, within the next 5 to 10 years, we'll be breaching 1.5, entering overshoot. And that the overshoot, as you see here, can take us back to below 1.5 by the end of this century, and that this is the best science can offer today. And if you look at this curve, you see immediately that it's a curve of danger. It's a curve that would bring us to 1.6, 1.7 degrees Celsius of warming over a period from 2030 all the way till potentially coming back under 1.5 by the end of this century. Now, this would, number one, mean more extreme events, more droughts, more floods, more heat waves. That you could say with certainty. The big question, of course, which is unanswered yet, is will the tipping point systems cope with this overshoot? The honest answer is we do not know, because the tipping point science is so far analyzed from permanent breaching, not temporary breaching. But there are indications that, for example, tropical coral reef systems are unlikely to cope with this. But the big question for this lecture today is, why would the planet come back? And we know the answer. The reason why the planet comes back is if we're able to come back into the safe operating space of the planetary boundary framework. So here you have it. Here you have the entire story, the story of the Anthropocene, the story of the Holocene as the reference point for the planet we depend on, the story of tipping points being the analytical tool we use to set the safe boundaries, and then addressing what are the Earth system processes that regulates the health of the planet. Those are the 9 planetary boundary systems, having control variables for all of them, which are data points that are quantifiable at global level, to quantify the functioning of those boundaries, quantifying all the 9, which is the green space, and then you see the yellow part is the uncertainty range in science. This is the equivalent of the burning embers of the IPCC. You are in the yellow zone, you're in the uncertainty range, what I call the danger zone. Exit that, you go into the red zone, where it's a high likelihood of causing irreversible changes. This is the 2025 scientific update. It was released in the New York Climate Week 3 weeks ago, and it showed the verdict, which is that we've gone from 6 to 7 boundaries being breached. You can see there that the ocean acidification boundary has just crossed the green line. The core message here, in my view, is the following. We have a climate crisis on our watch, and we're doing a major mistake and taking a major risk that when you have that pressure on the planet from climate change, from global warming, from injecting energy imbalance to the planet, how can we do the mistake then by at the same time eroding the resilience of the system? By breaching the planetary boundary on biodiversity, on fresh water, on nitrogen, on phosphorus, on oceans, which regulates the strength and ability of the planet to stay in a state dominated by dampening, cooling feedbacks. So we're doing a double mistake. We're kind of loading stress through climate forcing and weakening the capacity of the planet to deal with that stress. And this is, of course, what makes us particularly concerned and why we need to turn this around, but also, I would argue, why we need a planetary boundary framework to guide the future. I can turn this around as a very operational statement for Belém. We have evidence today to say the following. Even if we phase out fossil fuels to a completely fossil fuel-free world economy in 25 years, let's say we do everything right, and we celebrate in 2050, we will still fail, because the breaching of the biosphere boundaries will on their own push ourselves beyond 1.5. This is well established. So there's no choice here. Even if we focus only on delivery on climate, we need to pull ourselves back within the safe space also on the biosphere boundaries. Now, we have therefore challenged ourselves by going from a 7-year cycle of updates to now update the planetary boundary science every year. And we call this the planetary health check. We use kind of health analogies, so that's why you have these blood sample stripes. Green is the safe operating space. You see the danger zone, the uncertainty range, and red is the high-risk zone. The 9 organs of patient Earth on the list there. We bring the planet Earth to the doctor each year to do a full scan. And the verdict is that we have 7 of the boundaries outside of the green space. They're unfortunately continuing to move in the wrong direction. 2 of them are in the safe space, the stratospheric ozone layer and aerosol loading, air pollutants. These are 2 success stories, by the way. This is when we've been able, through environmental policies guided by science, to actually transition ourselves away from danger. So we can do it. We can be planetary stewards. And the question then is, what is the journey ahead? Well, the journey ahead is well understood. And here you have it. This is a summary of the IPCC journey to hold the magenta lines and come back to 1.5, which is phase out fossil fuels in gray, transform the global food system from source in dark brown there to sink, the kind of reddish color. By the way, that's not a small thing. That is, I would call that a green revolution. This is a major transition of the global food system. But we also need to scale carbon dioxide removal technologies. So we need to remove carbon also from the atmosphere in orange. And we need to sustain and secure in green and blue that the biosphere remains a friend, remains a system that sucks up 50% of the carbon and cools us back to within the safe boundary. So this is a sustainability transformation overall. It is the journey to safety. Now, to do that, you have to recognize that we are actually on a good way on the energy transition. And I'll just give you some pointers on 2 big transitions of solutions. One is the energy transition, one is the food system transition. By the way, if we succeed with these 2, we have come a very long way in returning to the safe space overall. Well, you've seen these exponential positive tipping point curves when it comes to the left, solar and wind share of electricity generation in the world. What I want to just two messages I'd love you to have in your mind here. Number one is that you see we're passing this 10% point, which is very significant because there's a lot of empirical evidence showing that when new technologies and new innovations penetrate more than 20% of market share, if they have better offers than the incumbent solution, they can tip over the logic in the entire market. This is Roger Everett's theory of diffusion of innovation. You all know it, the S-curve dynamics of exponential adoption. And we're starting to reach that point when it comes to renewable energy. So that's number one. And number two is look at the global south moving very rapidly as well. It's not just a global north issue. And we have so much evidence that on the mobility sector, we are in a race in the world today. This is admittedly data from two small economies, but it's very exciting stories of how 40% of vehicles sold in Denmark are today on an S-curve of exponential rise. And in Norway, 90% of all cars sold are fully electric. They've completely passed a social tipping point, despite not anymore subsidizing the transition. It's simply just a much better offer. And this becomes then the way the world moves. And this is what we're seeing in China. We're seeing it also in other parts of Asia, that we are on S-curve journeys. Admittedly on an early stage, admittedly going too slowly, but it's a very reassuring and new piece of evidence that we can, since 5-6 years only, say that solving the climate crisis is not utopia. It's not a fantasy. It is doable. We have the solutions, and we know that we can do this through these exponential rise curves. The second story is on food. We have just 2 or 3 weeks ago published the second Eat Lancet Commission report on healthy diets from sustainable food systems. This is a major, major global assessment which starts by asking the question, what does science say gives us the best life expectation in terms of what we eat? What is the healthiest diets if we want to care about our own personal health? And then secondly, we put the planetary boundaries around this and ask ourselves the question, how should that food be produced to be best aligned with the planetary boundaries? And the science shows the following. So on healthy diets, I won't go through the quantifications, but this is basically a summary of the plate. It's a flexitarian plate. It's roughly half plant-based proteins. It doesn't say that we need to eradicate animal protein entirely. You see dairy products there, chicken, fish, beef, with 5 servings per person per week. So red meat once a week, for example. It's a significant reduction in animal protein, but it's a balanced flexitarian diet. It has been quantified for all the components, more whole grains, more nuts, more fruit, unsaturated fats, lower salt, lower sugar. It basically confirms the national dietary guidelines that many countries in the world have. It's a diet, by the way, that fits very well with traditional diets across the world. And then we take that diet and put it into the planetary boundaries. So here you have the graph I showed earlier. On the global planetary boundaries, the 7 breached boundaries, the yellow part is the safe operating space, and then you have the danger zone in the red zone. And look at this. Here is the food system's responsibility. And this, I can tell you, even we on the Commission got quite shocked at this result. Just look at the portion of responsibility for breaching planetary boundaries of the global food system. It's the single largest source of greenhouse gas emissions, 30%. By far the single cause of loss of biodiversity. By far the single cause of consuming fresh water, 70% of blue water consumption. It is the driver of land system change. It is the driver, the number one driver of overloading of reactive nitrogen and phosphorus. And on novel entities, pesticides and antibiotic overuse were the 2 indicators we used, also well outside of the safe space. So putting it simple, if we could turn around the food system and eating more healthy diets, we would be on a very significant trajectory back towards a safe operating space. So we gathered 11 teams of modeling groups to be able to ask ourselves the question, can we feed 10 billion people within the safe operating space of planetary boundaries? And what would it take? Well, here are the results. The results show, to begin with, for land, greenhouse gases, blue water, nitrogen, phosphorus, that under business as usual, we are really on a track for danger. By 2050, we would add further breaching on all these boundaries. So the current food system is a driver of negative change. But if we would instead transition towards healthy diets, we would have a significant reduction in land expansion because you have less pressure from livestock and, of course, feed for livestock. For example, the linear process of chopping down rainforest to produce soy, transporting it over to Europe to use it in beef farms that then eutrofy coastal zones, break that linear system, reducing greenhouse gases. But look at the other boundaries, you would still be outside of the safe space. But if you combine it with the energy transition, the modeling shows that we could basically come back within the safe space on all the boundaries. So the conclusion is that if we can decarbonize the energy system and transition towards healthy diets and also reduce food waste, which is included here, and invest in sustainable intensification practices that are existing and scalable, you would actually have a return into the safe operating space within the next 25 years. So it just shows that it is possible, and therefore this final slide I think is quite important to close this with, which is that, you know, we are definitely scientifically concluding that we are in danger. We are outside of the safe space. The planet, when we summarize all the planetary boundaries, is placed, as you see here, outside of the safe space, but we're still within the danger zone. We're still in this yellow uncertainty range. The planet, as far as we understand today, is still dominated by negative feedbacks. I know that doesn't sound very pedagogic, but we scientists, we love negative feedbacks. It means dampening. It means a resilient system. It means systems that can dampen and cool. We're not yet in the red zone where the planet gets dominated by self-amplifying. We haven't started a hothouse Earth drift, which means that the window is still open to turn this around. And isn't that a positive story? Science now can measure and account for the safe space we have to respect. We have the scalable solutions. We know the two transformations that are the most promising ones to take us to a safe landing. And we know if we invest in them, we are the winners in the other end because we have a healthier people and a healthier planet. That is basically what I'd like to start with or stop with to share with you, that the safe operating space is really a guide to navigate the future for resilience, for habitability, and for stability. And I think that is why I'm so excited to be here with you in order to establish more close scientific collaborations also with National University of Singapore. Thank you very much.
Thank you, Prof. Rockström, for a truly insightful and inspiring lecture. We will now move on to the Q&A session. May we invite both Professor Rockström and our moderator, Professor Koh Lian Pin, to take their seats on stage. Ladies and gentlemen, a quick reminder. When you receive the microphone, please start by introducing yourself with your name and the organization you represent. Thank you. Professor Koh, the floor is yours.
Sorry.
Okay, wow, that was a very powerful, sobering, if not a little bit depressing presentation and seminar. Thanks so much, Professor Rockström, for sharing your insights and your research with the audience today. As we wait for the audience members to collect their thoughts and maybe also calm down a bit from the excitement and maybe a little bit of the anxiety that you may have caused, maybe I should start off with a simple question to take the conversation in a slightly different way as we prepare for other questions from the audience. Today, we of course have a very diverse set of audience. We have people from not just the industry, the public sector, the government sector, but also academics, and quite a large proportion of the audience are actually students. And I think the students will be very interested in understanding your career trajectory and how you got to be where you are today and to becoming such an inspiring speaker. So your career, for example, has taken you, as I understand, from applied water research in tropical regions to directing the Stockholm Environment Institute, as well as the Stockholm Resilience Center. And now, of course, you're co-leading the Potsdam Institute. For the students and early career researchers with us today, this international and multidisciplinary trajectory must be quite fascinating to them. So how did those early experiences working in diverse contexts shape your current focus on planetary boundaries and Earth system resilience? What lessons from your own journey might be most valuable, you think, for the young researchers navigating their own paths?
Yeah, thanks, Liam. It's a very good question, and I think, well, to begin with, you're right. I mean, I started my research really on the ground, exploring water use efficiency and water efficiency in rain-fed agriculture among small-scale farmers in West Africa. So I was basically running an hydrological cycle experiment far out in the African bush, but I was all the time having as a supervisor a late professor, she's no longer with us, Malin Falkemark, who was one of the leading global hydrologists in the world, who introduced the whole green and blue water concept and the whole water scarcity index for the world. So I was always forced to have one foot in the ground, so to say, and work with farmers on rain-fed small-scale agriculture, but also do quantifications of the global water cycle at the planetary scale. And I think that was one issue that actually kind of inspired me to always have this connection between the local and the global. That may have been one factor. The second is that while I have my original master's training in hydrology and soil science in the University of Agricultural Sciences in Uppsala, I then did my PhD in systems ecology and then went into climate science. So I've had the privilege of having a journey across disciplines, but always in the natural sciences. And then finally, I think, it's largely, I don't have an explanation of the kind of engagement in lecturing and things like that. It's more that it's just that I simply enjoy being an academic, I guess. So I think one advice is that to have fun along the way is quite good. I mean, despite the seriousness of the topic.
But just to follow on that, you're not just an academic, right? I think you are being very humble, and also not just a world-renowned scientist. You are actually a very outspoken advocate for climate action, and you collaborate quite frequently with policymakers, with industry stakeholders, and also, of course, the broader public. And some in academia may worry that advocacy could compromise scientific credibility. So what are your thoughts on that?
Yeah, no, that is an important question. And so to start with, I've drawn the conclusion that whether we like it or not, we academics, we scientists cannot remain in the lab and only be guided by, the traditional way we measure progress in an academic career, namely to publish scientific papers, that we need to also bridge it with policy, with citizens, with society at large, that we have a responsibility for that because of what the evidence is showing. And for me, that has taken me on a journey where I find also a responsibility here, because we're not so many of us in the Earth system community that really has connections to the business community, the policy community, to decision makers around the world. And therefore, I find it to be a particular responsibility to engage in that bridge, because, 3 weeks back, I was asked by Secretary General Antonio Guterres to give the science update at the Heads of State Summit on Climate in New York. And of course, I find it I think it's a responsibility to say yes to that kind of task, because how uncomfortable it may seem, I think it's important for us to be a bridge, to really provide the state of evidence to political leaders in this case. So I think that is important. But at the same time, we continuously, every week essentially at the Potsdam Institute, have discussions on having this firewall between the integrity of the science and the opinionated viewpoints in advocacy. That is incredibly important for for our ability to be credible voices in that bridging with society, that we stay firmly in the camp of evidence. And as you know, as that is a fundamental feature, and therefore it's something that, for example, at the Potsdam Institute, we have a very, very strong, let's say, culture on that. That you know, we talk. Our talking points are based on the peer-reviewed evidence that we have, not anything else. But admittedly, this is I think that's why you asked the question. It's not easy today, as you can imagine, because of the you know, really, really difficult situation through misinformation and disinformation and all the populism and denialism we see in the world, and the tendency of backtracking of climate action, and that we are seeing assaults on science, and we're seeing also renewed pressure on us as climate scientists. So of course, it's a delicate position to have, but I think we've learned through many years of being confronted by denialism of how to handle it, how to be on the right side of the truth line in order to avoid being accused of being like an opinionated advocate. But it's you know, you have some classic stories here of my dear friend and colleague Jim Hansen, who came to a point where he just felt that he had to become more activist, and started to, and I have full respect for his choice to be more, you know, out on the streets and kind of in the barricades demonstrating, and the way he was accused then of no longer being a trusted voice in science, which I completely disagree with, but it is something that one always needs to be aware of. And that's why one conclusion to close this, I always say, I say to my students, I will say it here as well, that I think it's more important that we scientists hold hands with other stakeholders rather than take upon ourselves to, you should not ask from an academic to have the opinion, to have the solution, and the diagnostic. You know, it's good to have one of those three, but I think we should predominantly provide the evidence, and then we can hold hands and work together with civil society people, you know, Fridays for Future people, you know, activists are fine, but we should not take over that role. I think one should actually respect the role of a scientist and see that as a precious asset in society.
Great. Talking about holding hands, I would now like to open the session to the audience. Please hold up your hands, and a mic will come to you. Before you ask your question, can I just request that you state where you're coming from, if you're a student, which department or faculty you're from, if you're from the public, which organization you're from, and then of course give your name. That will help to give some context to your question for Professor Rockström.
Hi, my name is Dr. Radhika Bhargav. I am a research fellow at the National University of Singapore. My question is regarding international agreements and frameworks like the UNFCCC or the Global Biodiversity Framework. So looking at the Montreal Protocol, which helped curb down the release of CFCs, which ultimately helped repair the ozone layer. We saw from your lecture today that the ozone depletion is within the planetary boundaries. So what can UNFCCC or the Global Biodiversity Framework and the countries that have signed these agreements learn from the success of Montreal Protocol and bring back some of the planetary boundaries within the limits? Thank you.
Yeah, thanks. I love this question. It's such an important one. And of course, the first answer, which is very simple, is listen to science and act accordingly, because that's exactly what the world did with the Montreal Protocol. The world listened to science and acted accordingly by signing the Montreal Protocol in 1987, and that was a remarkable achievement because nobody had seen an ozone hole, and still the world trusted science in the conclusion that this was an existential threat and that it was caused by the chlorofluorocarbons that we use to power and to cool our refrigerators, run our air conditioners, and power all our our small push buttons for shampoo, etc. And this was something of a remarkable achievement. The second unique feature of the Montreal Protocol is that we didn't have a phase-out plan for chlorofluorocarbons. We forbid them. It was a red line in the sand. It was a mandatory regulatory framework. It was legal and it was mandatory. And I think both the UNCBD and the UNFCCC need to have a sobering relook at its work, recognizing that the Paris Agreement for climate was an extraordinary achievement, admittedly. It has a legal framework to stay well below 2 degrees Celsius and aim for a landing at 1.5. And I really hope that you exit this room agreeing with me that 1.5 degrees Celsius is not a target, it's not a goal, it's a limit, it's a boundary, it should be taken very seriously. The problem with the Paris Agreement is that below that, it is voluntary. The content in the nationally determined contributions, the NDC plans, is up to every nation's voluntary work, and it doesn't add up. This is what adds up to the 3.1 degrees Celsius we just discussed earlier. So that is another lesson from the Montreal Protocol, that having more mandatory regulatory quantifications guided by science, I think, is something that we're lacking in the Paris action plans. And can that be corrected? I would argue yes. There is a discussion right now within the UNFCCC. Simon Steele has listened to us in science, arguing for the need of a COP reform. And the COP reform, we argue, should say the following. Dear world, 30 years of climate negotiations, we should now celebrate. We don't need any more negotiations. Everything is in place. All the text, we fought through all the text. It's not perfect, but it's good enough. Now we go into the final stretch of implementation, and we need to deliver. And the delivery has to be guided by science, and it has to have compliance. It has to have accountability and compliance quantified down to the country level. And this is inspired by the Montreal Protocol. So I think there's a lot to learn from there. I'm sure someone in the audience has some critical remarks about this, and let me just respond to one immediately, because the reaction is always, well, but the Montreal Protocol was simple because it was one industry and a much more narrow problem. Admittedly, that was a more narrow question. The energy system penetrates the entire economy. Chlorofluorocarbons penetrate to just the kind of the chemical industry. But there is a similarity, which is the following. The Montreal Protocol succeeded not only thanks to the science and to political leadership, it also succeeded because the industry had solutions. And they were scalable solutions that gave equal or better outcomes. It was this Roger Everett combination that, it wasn't a lose pathway, it was actually, you adopted the planet stabilizing Montreal Protocol technology, and as a citizen, we couldn't care less if we had bleached or unbleached paper. It was the same level of human well-being. Well, we've reached that point for energy. Actually, the outcome of a fossil fuel-free energy system is higher human well-being than with a fossil fuel-driven one. So we have a Montreal moment on climate. And we only have it since a few years. So I would say that, inspired by the Montreal Protocol, we should be able to be, acting more according to the Montreal logic, which was to really combine policy, science, and technology in the journey ahead. It's been so popular to say, well, even if we can agree on the climate problem, it's too expensive, it's too difficult, and we definitely need to let the developing countries go slow into the future. I mean, why let the poorest countries be the losers again by staying in the coal mines? Why not let them go into the future? We know what the future is. The future is a green, modern, attractive, secure, healthy, technologically driven, fossil fuel-free, decarbonized world economy. This is well established. The question is not if we go there, the question is, will we be too late? And therefore, I think that this is a moment to reflect back on the Montreal Protocol and use that as an engine. You can almost think that I planted this question, don't you? But I didn't, I promise. So, thank you.
And to prove that he didn't plant the question, maybe I'll ask, I just cannot resist asking you a follow-up question, which may be a bit cheeky. You mentioned the role of policy, regulations, and so on, and basically drawing a red line in the sand to stop us from doing certain things. For example, in the CFC example, in a lot of today's discussions, current discussions around climate, carbon emissions, and so on, and even biodiversity, there's a dominance. There's a dominance of conversations around the role of markets, right? Carbon markets, carbon offsets, biodiversity offsets. So, what do you think of that? Do you think, and that to the extent that some people are thinking that we will not be able to scale our solutions if we don't rope in the markets, rope in the private sector to help us to provide the financial resources to help us scale some of these solutions. So what do you think of the role of markets vis-a-vis regulations and policy and so on?
Yeah, no, this is an incredibly complicated question. And it's very timely that you ask it, because 2 days ago, we published a Nature commentary on exactly this topic. So I think it should be open access, so please consult it if you want. It was written with a number of Australian colleagues, and it puts forward all the arguments to be very critical of the voluntary carbon market and to criticize offsets. And it criticized on 3 accounts. Account number 1 is the classic one, that the voluntary carbon markets have very limited permanence, that it's very difficult to prove that your investments in nature-based solutions through offsets can really compensate for a fossil fuel-based emission. Number 2, which is really something that I had underestimated, which is that the voluntary carbon market contributes to lower the carbon price because it's so much cheaper than getting rid of carbon from fossil fuel emissions. So it actually distorts the market. It doesn't help the market. And the third and final and most serious argument is that it doesn't work. Because what I showed you on the journey ahead, there is no room for offsetting anymore. The remaining carbon budget for fossil fuels is so small that we now need to both phase out fossil fuels and secure nature-based solutions and transform the food system simultaneously. So you cannot invest in one voluntary carbon investment and use it as an excuse for moving slowly on fossil fuels, because then you double count. You have to deliver on all the buckets. And we're going to publish on this also in a paper that is being submitted right now. That said, we need nature-based solutions. We need to invest in nature. We need to have all hands on deck to secure that we don't lose the buffering capacity. We need to bring ourselves back into the biosphere boundaries, as I told you. So everything I've said kind of collides with the fact that the only incentive in the economy to invest in nature-based solutions is through offsets. That's the only thing that counts in a boardroom or among shareholders on a stock market. So how do we solve this conundrum? And admittedly, there is no solution today, but we need to find ways of allowing and creating incentives to invest in nature and decarbonize the energy system without using them as an accounting system allowing for slow phase out of fossil fuels. And I know that this is, of course, a challenge in a country like Singapore. So this is, it's probably a whole new seminar.
Great. We can take maybe 1 or 2 more questions.
Hi, my name is Marla. I'm the founder of the Eco Chapter, and we are an environmental education and storytelling consultancy. So my question's a little bit long, sorry, because I tell stories. So most people on the planet are quite apathetic to science, and some presidents also think that climate change is a joke and a hoax. So I think today also your co-counsel said that your talk was depressing and causing anxiety. But this is how most people react to the science. And so they don't want to listen or they don't want to hear it. And like you said, it's also too big, too difficult, and too expensive unless it becomes an existential threat and mandatory no-no. A lot of science is also inaccessible to most men, and they hear doom and gloom on news reports. So then this just causes more apathy and eco-anxiety and climate fatigue. And so people, especially after COVID, are just taking everything they can. And, YOLO, FOMO, and in Singapore, we call it kiasu. But then you also ended your speech by saying there was a positive story that we want to continue. But it seems like to most people, we just hear all the doom and gloom rather than hopeful stories. So in what I'm doing for my work, and there's a few of us that have just published a book called Dreams of Unwritten Futures, and we talk very much about regenerative economies and decarbonization, like you mentioned, and a world based on reciprocity and living with connection with each other and nature. So with your talk, you started by saying, let me tell you a story, and you also ended up by saying that this is a positive story that we're trying to share. And you also used metaphors of the 9 organs of a sick patient Earth. So my question are, how does then storytelling fit in with the science? How do we combine, like you said, hold hands with stakeholders and get science more accessible to the general masses in order to build a story of a positive, better future narrative? And so what are your thoughts on the role of literature and imagination and storytelling in helping people to cross that bridge from apathy to action? Thanks.
Yeah, thanks. No, and thanks for your work. And I think storytelling is incredibly important. And I think, this is something that we all have different views upon. But my view here is quite firm, that I think we have a responsibility as scientists to put all the cards on the table. In any other part of our lives, we always expect to get the full diagnostic. You wouldn't go to your doctor with cancer and be happy if they tell you that you have a cough. You want to have the full diagnostic. You want to have the cure as well, but you want to have the full truth. And I stay by that. So I don't call this doom. I don't call it something that is meant to frighten anyone. But when you think of it, in any other part of our lives, we expect to know the risks. We buy insurance for our houses because we know that there's a minuscule risk of a fire, but just knowing that it could happen means that we buy the insurance. And this is exactly what this is all about. It is about the insurance of giving our children a future on planet Earth. And I think everyone should know that story. But it has to be, you're right, combined with the story of the sun rising in a future of responsibility, of prosperity, and of justice. And there are 2 issues here. One is that we have completely failed in that storytelling. I would even argue that the reason why we have a president in the US that today considers climate change being a hoax and putting it in the same basket as everything that he portrays as nonsense was not necessary. I think it's quite coincidental, actually, because when you look back at US history, it's been the conservative Republicans who've been the masters of defending the Clean Air Act in the US, establishing the Environmental Protection Agency. It's been a conservative agenda point of defending independence, freedom, private property, clean air. Don't touch my right of the cowboy landscape, basically. And then suddenly we fail because we allow ourselves to have a storytelling which is too much focused on sacrifice. That we have an environmental problem, we humans are causing it, we better back off, we put fences, and remember that solving this problem means sacrifice. And that story has become so dominant that we have got stuck there. And I think this is why we get a lot of critique. When in reality, we know today that the story of sustainability is the story of winners. It's the story of modernity, and it's the story of the future. And how come that we have failed in telling that story? And I think it's because the whole climate agenda and everything that I've been talking about has been parked in the environmental camp. We fall under the Ministries for the Environment, we fall in the environmental NGO community, we end up in one corner of society when we should be at the center of society. We should always be next to the Prime Minister. We should be at the UN Security Council. We should be in the Pentagon. We should be the ones really informing the health agendas. That's the position for the sustainability agenda. And why isn't it there? And that is what has, and I think one reason why it isn't there is that we have failed in storytelling, but also that we have been able to lull ourselves in a comfort zone because the planet has been so forgiving for such a long time. You know, Mother Earth, she's been okay, and she hasn't complained. No invoice has been sent back. It's very recent that this has started to happen. And I think that is part of the story. So I'm not so nervous about hitting a bit hard with the evidence of truth, but then combining it with the evidence of opportunity. I totally agree. And we were joking about this last night in dinner that, you know, give a scientist 30 minutes with Donald Trump and we'll turn him around to be a climate champion. And I really challenge you on this one. If you open a door, we will win this. And I think that's part of the story as well.
Fantastic. We have maybe time for just one last question. Quick one, please.
Okay, thank you, Professor Rockström, for your quite inspiring lecture. I am Hai Tongsun, Associate Professor from Yale School of Medicine. Here we have a question, which is also a question from the PHAS research team led by Professor Gordon Liu, that do you think whether it is meaningful and worthwhile to quantitatively assess the health burdens like morbidity and mortality under each individual PB, and then identify the priority environmental issues for each country to regulate? Or furthermore, will such population health-oriented assessments contribute to refining or redefining the safety thresholds for specific PBs in terms of population health? And again, Prof. Gordon Liu yesterday wants me to convey his gratitude once more for your kind advice in helping us establish the PHAS framework. Thank you.
No, thanks a lot. So what you're referring to is a meeting we had yesterday with Professor Gordon Liu at Peking University. They're spearheading a really exciting initiative on planetary health. I find this to be one of the storytelling parts that we have missed so far, which is to connect the planetary boundary story of the health of the planet with the health of us humans. And that we have so much evidence that breaching boundaries lead to immediate impacts on our own health. And I find it remarkable that, you know, the statistics show that 7 to 8 million people die prematurely each year because of air pollution, breaching the aerosol boundary. Up to 15 million people die prematurely each year because of unhealthy food, one of the major drivers to come back into the safe operating space. These two numbers alone far exceed the number of people that died prematurely during the COVID pandemic. So when it comes to a pure health crisis, we act as a global community. But when it comes to planetary-driven health crisis, we just seem to internalize it as part of normality. And I think, therefore, we need to have this planetary health diagnostic of how many people are impacted for each of the boundaries. And finally, I don't mind at all to say, as a climate scientist, that I think the health story is much more powerful than the climate story, because it comes to your heart immediately. Everyone wants to have a good health for yourself, your children, and your family. And I think, therefore, we should work much, much closer to connect these two areas of science. And I think we're now, thanks to the collaborations, not least with National University of Singapore and with Peking University, we can push this forward in a very active way.
Well, on that hopeful note, I hope you will join me in giving another round of applause to Professor Rockström for his lecture and answers. Thank you.
Thank you, Professor Rockström and Professor Koh, for a fascinating and profound discussion. Before we conclude, we would love to capture this special moment. May we invite both professors to remain on stage, facing the screen for an audience Wi-Fi photo. Ladies and gentlemen, please remain in your seats as we take the photo. Thank you. Ladies and gentlemen, this brings us to the end of this afternoon's session. We hope you found it engaging and inspiring. If you wish to revisit the important points shared today, the video recording of this event will be made available soon on NUS social media platforms. Do keep a lookout for it. We would also like to invite you to enjoy the light refreshments that are available just outside the auditorium. Thank you once again for joining us and have a pleasant evening ahead.